Final review and exam day preparation. This lesson is designed to give learners a comprehensive final review before taking the ASE certification test. It will revisit all of the major topics covered throughout the course, from engine repair and diagnosis to HVAC systems and electrical components. In addition, we will review essential troubleshooting techniques that will help students diagnose and resolve vehicle issues during both the exam and in real-world applications. A strong grasp of these key concepts is critical to excelling on the ASE certification test and succeeding as an automotive technician. Introduction to ASE certification. Before diving into the technical material, it's important to understand the ASE certification process itself and its significance in the automotive industry. What is ASE certification? ASE stands for the National Institute for Automotive Service Excellence, which is an independent organization that provides certification for automotive technicians. Why ASE certification matters. Certification is a recognized industry standard that demonstrates a technician's competence and expertise in automotive repair and service. ASE test structure. The ASE certification test consists of multiple-choice questions covering a wide range of technical topics and requires a practical understanding of each system within the vehicle. Overview of ASE certification test. The test consists of questions on engine performance, transmissions, brakes, HVAC systems, and other key vehicle systems. The goal of the exam is to test both theoretical knowledge and practical application. You must understand the operation of systems, diagnostic procedures, and repair techniques. Engine repair and diagnosis, A1. Engine repair and diagnosis is central to many automotive repairs. Diagnosing engine issues accurately is the first step to providing effective solutions. Key concepts. Common engine problems: misfires, poor fuel economy, overheating, rough idling, and exhaust problems. Diagnostic tools. OBD2 scanner, compression tester, fuel pressure gauge, and multimeter are essential for troubleshooting engine issues. Symptoms of engine issues. Look for indicators such as a check engine light, CEL, unusual engine sounds, poor performance, or emissions failures. Troubleshooting techniques. Use OBD2 codes to identify which system or component is malfunctioning. Perform a compression test to assess cylinder health. Test the fuel system and ignition system for functionality and efficiency. Automatic transmissions and transaxles. A2. Automatic transmissions and transaxles are complex systems that require precise control for smooth operation. Key concepts. Components. Torque converters, clutches, planetary gears, and fluid systems. Common problems: slipping gears, delayed shifting or no shifting. Transmission diagnosis. Use transmission fluid pressure gauges, check for leaks, and ensure the proper functioning of the shift solenoids and valve body. Troubleshooting techniques. Perform a fluid level check and assess fluid condition for contamination. Use pressure testing to determine hydraulic system issues. Manual drivetrains and axles. A3. Manual transmission and drivetrain systems are simpler than automatics, but still require attention to detail for optimal performance. Key concepts. Manual transmission components. Clutch, flywheel, gears, and synchronizers. Common problems: hard shifting, clutch slippage, or no engagement. Axle diagnosis. Look for worn CV joints, axle seals, and differential issues. Troubleshooting techniques. Inspect the clutch master cylinder and slave cylinder for leaks. Perform a road test to diagnose issues with the shifting mechanism or differential noise. Suspension and steering, A4. A smooth, safe ride depends on a properly functioning suspension and steering system. These systems work together to ensure control and comfort. Key concepts. Suspension components. Springs, shock absorbers, struts, control arms, and bushings. Steering components. Rack and pinion, steering column, power steering pump, and fluid. Common problems: uneven tire wear, poor handling, steering play, or noise. Troubleshooting techniques. Perform a visual inspection of suspension components for wear, leaks, or damage. Test steering responsiveness and inspect the power steering fluid for proper levels and leaks. Brakes, A5. Brakes are critical for vehicle safety. Proper braking performance relies on the integrity of several key components. Key concepts: brake system components, brake pads, rotors, calipers, master cylinder, and brake fluid. Common problems: squeaking, grinding, soft pedal feel, or uneven braking. Brake diagnosis: use brake fluid testers, check for leaks, and inspect pads and rotors for wear. Troubleshooting techniques: check brake fluid levels and inspect brake lines for leaks. Test brake pressure and perform visual checks of the rotors and pads for wear or damage. Electronic systems. ASE. Electrical systems power nearly every modern vehicle component. Understanding these systems is essential for diagnosis and repair. Key concepts: electrical system components, alternators, batteries, wiring, and fuses. Common problems: no start, dim lights, or intermittent electrical failures. Diagnostic tools: use a multimeter to measure voltage, resistance, and current. Troubleshooting techniques: inspect battery voltage and charging system output. Use a voltmeter to test for power to various components. Check fuses, relays, and wiring for continuity. Heating and air conditioning. A7. HVAC systems regulate the temperature and air quality inside a vehicle. Proper diagnosis and repair of these systems is essential. Key concepts: HVAC components: compressor, condenser, evaporator, and blower motor. Common problems: no cooling, weak airflow, or strange odors. Refrigerant types: understand the difference between R134A and R1234 refrigerants. Troubleshooting techniques: inspect refrigerant levels and check for leaks. Test blower motor and compressor operation. Use an IR thermometer to measure temperature across the evaporator coil. Engine performance. A8. Engine performance diagnostics are key to understanding how various systems impact a vehicle's power and fuel efficiency. Key concepts: fuel injection and ignition systems. Proper fuel-air mixtures and ignition timing are critical for performance. Common problems: misfires, poor acceleration, and stalling. Diagnostic tools: use OBD2 scanners, fuel pressure gauges, and compression testers. Troubleshooting techniques: check fuel injector function and spark plug operation. Test compression and fuel pressure. Use an OBD2 scanner to detect trouble codes related to performance. Conclusion and recap. In this lesson, we covered a thorough review of the key concepts from all major topics on the ASE certification test, including engine repair, transmissions, brakes, electrical systems, and more. We also reviewed troubleshooting techniques to help you diagnose and repair common vehicle problems. You are now prepared and confident to take the ASE certification test.